So in the last video, we talked about the vertical shift up and how that was done by the y-intercept, or vertical shift down. Also, we could see that by the y-intercept. If the y-intercept is positive, it went up from the parent, and if the y-intercept is negative, it went down from the parent. So remember, we're comparing everything to our parent function. So on this side, notice our equations are a little different. There is no plus b here, which means we're going to be looking at the effect of the slope. So we're going to do the same thing we did before. We're going to go ahead and mark our slope, which goes in front of the x, and our y-intercept, and we're going to go ahead and we're going to put those values in. So this here is 3 and this is 0. So when I simplify it, this is 3 times x, which is 3x, plus 0 doesn't add any value to it. So I'm just going to leave that as is. Okay, now we're going to substitute this in. So notice I have a spot in front of that x. Well, that's my slope. And my slope is 3. That's not changing. So this is going to be 3 times the value of x, which is 2. 3 times 2 is 6. This would be 3, because that's my slope, times my input of 1, which is 3. This would be 3, because that's my slope, times the input of 0, which gives me 0. Then I have 3 times my input, which is negative 1, which gives me negative 3 when I multiply them. And then I have 3 times my input, which is negative 2, which gives me negative 2 times 3 is negative 6. Okay, so now I have my input and my output. So when x is 2, y is 6. So that's that point right there. When x is 1, y is 3. And we have 0, 0. And then when x is negative 1, y is negative 3. And when x is negative 2, y is negative 6. So a couple things that you can see are a little different here. Notice how all these points were closer together when we did them. Here, they're spread apart a little bit more. They're steeper steps. So now I'm going to put my line through those points because there are values between the values we calculated. So let's look at what happened when we compare the way this looks to this. If I were to take a yellow highlighter, which is what I would like you to do, and put it here where the parent, remember the parent started at 0, 0 and then went up 1, right 1, so up 1, right 1 all the way. So that's my parent. And then it goes the opposite direction. So you need to memorize what your parent looks like. So that's my parent in yellow. Let me zoom in a little bit. So when we compare this new function to the parent function, we can see that the slope got steeper. So the slope got steeper, and I'm doing an arrow so that you can think if it went from this steepness to this steepness. Okay, so it got steeper. We're going to write got steeper, okay, than the parent. So the transformation, we would say it got steeper. It's also called a stretch, okay, because it stretched It's stretched to your y-axis. Notice it got closer, it got stretched up. So I want you to imagine if you were to pull this, it starts getting skinnier and taller. So here we're going to say this is a vertical stretch. So now what I would like for you to do is I would like for you to try the next one on your own. Go ahead and see if you can fill this out, and then we'll check it together when you're done. So when you go to do this, you're going to find that you had some difficulty. This part was fairly easy. My slope is 1/3. My y-intercept is 0, adds no values. So my equation is y is equal to 1/3 x. You might have had some difficulty here. So 1/3 times 2 means I have 2 1/3, so 2/3. 1 times 1/3 is 1/3. 0 times 1/3 is 0. And this is just negative 1/3 and negative 2/3. So I'm looking at this and I'm like, well, those are not nice integer values. The only thing I can plot is 0, 0. Okay, so I started with 0, 0. I can't plot 2 and 2/3 and 1 and 1/3. So what I'm going to do is I know that the slope is 1/3, which means I rise 1 and I go right 3. So starting here at 0, 0, I went up 1, right 3. Sorry about that. They keep doing announcements. So I started at 0, 0, 0, and my slope is rise 1, right 3. Rise 1, right 3. Rise 1, right 3. So that's how I got those points. Then here I'm going to fall 1, left 3, fall 1, left 3, fall 1, left 3. So that's how I got my points, because these were not helpful. So that's an example of why you need to know slope. Notice my y-intercept was at 0. It's the same as the parent function. Let's go ahead and draw in our parent function so we can see what happened. So remember, my parent is up 1, right 1, up 1, right 1, and I'm going to do that all the way. And then down 1, left 1, down 1, left 1. I'm going to go all the way the other way. So the reason I'm doing this is so that I can compare it to the parent. So if we looked at the one above it, notice it got pulled up. It got steeper. This one here, and I want you to think of this word, this is being pressed down. Okay, so it's not as steep. So this one here was pressed down, and it's not as steep. Remember, as the parent. All right, as parent. Okay, and remember the parent is in yellow. Okay, so I said press, so this is a compression. So this here is going to be a compression by 1/3. Okay, the one above was a stretch by 3. So that's meaning that y is going to be 3 times bigger than what x is, because I'm multiplying x by 3. So this is going to be a compression, because notice it has the word press in it. So that presses down. It has the word press in it, compression. Okay, so now we have something funny going on here. We have this absolute value, absolute value. So absolute value just means it doesn't matter if it's positive or negative that we put inside. It has to do with what is the number. I don't care if it's positive or negative. So when we look here, our slope is 3. That gave us a stretch. So if I pretend to put the number 3 in here, if I pretend to put 3 in there, the number 3 is bigger than the number 1. So if your slope is bigger than 1, it's going to be a stretch. For the one below it, let's look at that slope. That slope is 1/3. Well, 1/3 is smaller than 1. That gave us a compression. That pushed this, our line, down from the parent. So that means that if we imagine this to be 1/3, it can be 1/2, 1/5. 1/3 is smaller than 1. So that gave us a compression.